Hey guys, so I'm looking at the data again in Excel. What we did before, this is the data clean sheet, which you can use for Power BI or do any kind of analysis. So what I did in the last video was to look at the pivot table time series across time for volume and split by continents, right? Then we saw that as the continents are closer, they are more correlated, the change in volumes. So now we split the continents up into countries, and we do the same thing. So by countries, we have the time series, and we index it to look at the changes over time. There's a big one here for a particular country, which is Qatar, because I think there was a big jump at the start of the year, so that's why it's like the anomaly. But anyway, the changes can be measured, so correlation can be measured, and here we have, if I zoom out, we have the correlation matrix. It's a 67 by 67 matrix, right? So needed to write a bit of a script to process, like, we have to go through the entire script here and find out which one is the most positive correlation and the most uh, negative. So I wrote a macro. If you click on Y1, it will calculate the correlation. The macro is inside the sheet itself here called CorrelSort here in sheet 14. So if you click on this, it will then generate the output here to sort them by the most correlated to the least correlated. I just put the top 50 and the bottom 50. Then here are the results right here. So this reads the results, and here we just list out the country names and correlation sorted from the highest, most positive, all the way down to the last 50, which are the most negative. So that's in red. Just visually looking at it, you can't really see any. It's not obvious with the distances. They're different for different country pairs, but maybe on average we can see something. So we do some hypothesis testing here. Here on the left, I put so group A would be the top, most positively correlated countries, right? And on the right, group B would be the most negatively correlated, the last 50, the most negative correlated countries. So we look at this, the average correlation here for the group A is positive 76%, whereas the other one is the other direction, right? Negative 73%. So on average, each of these, there are 50 in each group, right? So I'm using group A here as a reference for the t-test. So here the average distance for all these country pairs is about 6,039 km, whereas the average distance here is about 7,900, so almost 2,000 kilometers more for group B, for the negatively correlated one. So I mean, intuitively, it seems like the more negatively correlated it is caused by the distance between the countries, because it takes time for the volume to of containers to travel from one port to another, from one country to another. So it kind of makes sense, but just to formalize it with the t-test, so we asked the question is where you are using just this number here, the group A's mean as a reference, and we're doing the one sample using group B. So is the group B mean distance different from group A mean distance, right? which is given by 6039 kilometers, right? So, and here we did the usual. We calculate the mean, the standard deviation. We calculate the sample standard error, which is the standard deviation divided by square root of the count 50 data points, and then we subtract we find the difference in the sample mean error compared to group A. So we have the sample mean error, and then we have the sample standard error. So for the test statistic, what we do is we compare the two. So we compare the sample's mean error versus the sample's standard error to kind of know where on the right. So if there's this uh, if there's this chart here, if I can draw like uh, if this is like the error, which is the sample mean minus the mean of the hypothesis, right? Where does that fall? If this is the zero, right? Or rather, no. Let me see. So we're comparing. If we divide one by the other, this is like a one. This is like a one. Right. So if we divide the test statistic, right? Uh, we're checking. So if this is like a one, where the sample mean error is the same as the sample, right? So this is the test statistic. This is the test statistic, right? So that's uh, the sample mean error divided by the standard error, right? Right. So if it's a one, that's right here, and then say that it's the same, you can't conclude anything. But if it's more than that, it's like 2.94 here, right? So that's like 2.94. Then you're very much on the away from this, right? There's a certain confidence. Since this is a two-tail, so uh, basically you compare that to the p-value, and then at 95%, we can, at the 95% confidence level, you can reject the null hypothesis. So the conclusion is yes, it's different. Okay. Then we did the same thing after that. To Instead of a two test, we did a one tail, right? So I'm gonna switch the tabs. So with the two tail, the formula is here, the t dot this dot 2t. If I change to a one tail, it becomes t dot this distribution dot rt, right tail, right? So for the right tail, the question we're asking here is right. So this is again the test statistic, which is the sample mean minus uh, the reference mean, and then divided by the standard error. So that's the sample error divided by the standard error, and that if it's a one, it is inconclusive. If it's more than that, and here we're doing a left tail. So right. Okay, let's see. Right, the p-value here. Right, so the let me back up a bit. Okay, so there's a test statistic here, which is then used to calculate the p-value. So the p-value here turns out to be 0.0025. That's here, right? So this guy here is 0.0025. 0.025, right? Uh, so that's the chance that it's true, but we reject the null hypothesis, right? So that's very small. Earlier, for the two test, right? This is the two-tailed is 0.0050 because each side is 0.0025, and this one is also 0.0025. So together they get 0.05, 0.0050, right? Anyways, much less than the 5% level of significance, which is the alpha over here. Yeah, so this is the two-tailed test, and this is the other tab is the one-tailed test. And in both cases, we reject the null hypothesis. So it's different. Not only is it different, it's greater than. So the distance is greater than in group B, the mean distance, right? So our conclusion is that for correlation being more negative, the distance is greater, and that's what's causing. So distance is causing the correlation to become more negative. Yeah, and that's all I have for this video. Thank you.